Welcome to lab lesson number 1, lesson 2 of module 1, security behind ignoring passive interface setting. When configuring a routing protocol, the interfaces of routers cooperate with each other to update routing status of the network. An interface that sends routing updates and/or processes received routing updates is called active interface. In some routing protocols, such as OSPF v3 for IPv6, all interfaces are active by default. On the other hand, a passive interface does not allow outgoing and incoming routing updates. In Cisco router, we use passive interface command to make a router stops sending and receiving hello packets over an interface. The security risk behind ignoring passive interface setting is represented by routing table poisoning, RTP. Allowing to receive outside updates may attract hackers to harm the routing protocols or routers inside the LANs. This could be done easily by running a virtual Cisco IOS router and configuring OSPF v3 to send false updates towards routers inside the LANs. False updates could be false router failure or non-existing router path changing. The solution is to select precisely interfaces to be configured as passive. This will prevent routers from sending outside routing updates and processing received routing updates from the outside. This is the topology that we are going to use in our practice in this lab. We have network number 1, network number 2, network number 3, network number A, network number B, network number C. All the networks will have prefix ID of 2001 DB8 11AA : 64. We have also 4 PCs, Alpine 1, PC3, PC4, and Alpine 2. All these PCs are equipped with Linux operating system. The ultimate goal of this lab is to explain the security risk behind ignoring passive interface setting.
R1, R2, and 3 are configured with IPv6 addresses, and the OSPF routing protocol is configured and running on them. Let us show the running config of R1, for example. We can see that the IPv6 unicast routing is enabled, and also IPv6 Ceph is enabled. And for the interfaces, the IPv6 address are configured for F00 and for S10 and for S11. The OSPF routing protocol is running on these interfaces as well, here and here and here. Now let us complete the configuration of the topology. I'm going to start Alpine 1 and Alpine 2 host and view their IPv6 addresses. And also I will check the connectivity between them. Open the console for Alpine 1. And open the console for Alpine 2. Let us check the IPv6 address that has been assigned to Alpine 1 by R1 ifconfig. This is the IPv6 address that has been assigned using the Slack process by R1 in Alpine 2. Let me check its IPv6 before. Yes, this is the IPv6 address that has been assigned to Alpine 2 by using Slack, okay, on router R3. Okay, now let us check the connectivity between them. So I'm trying to ping, remember, Alpine 2 in a segment and Alpine 1 in another segment, just to check or verify the OSPF configuration. Ping from Alpine 2, Alpine 1. Okay. We have connection between the two hosts. Let us go back to our topology. Because of F00R3 is active interface, it is now broadcasting a hello message to all routers in the 2001 DB811AA:3 network, which means it is now showing an information about the routing information of the network. Any routing information in the network now is showed up outside the network by this interface because it is right now set as active interface. Let us open the Wireshark to capture these packets, the hello packets. Start capturing. Okay. Start the Wireshark. We can see here that the hello packet is initiated from the R3. This is the link local address of R3 to all router multicast address. And the hello packet is initiated periodically. Why this happened? Because now the F00 is active. The most dangerous scenario when there is an insider attacker working on this PC, for example, and there is a new router is added. So let us add a new router. Of course, it will be configured with OSPF routing protocol. So I'm going to configure with OSPF routing protocol. Starting it. Then open the console. I'm going to copy and paste the configuration just to save the time. Okay. Very good. Verify the configuration. Yes, now I have F00 is enabled and it has an IPv6 address. Adding a new router means a new adjacency is added to the OSPF. And because the F00 is active right now, it will send the database description message or DBD packets with type 2 that contains the content of the link state database. Let us open the Wireshark and see what is happening. We can see here that this packet, which is DBD, okay, OSPF DBD packet, has been sent from the router R3 to the new router, actually, to the new router, just to inform him or to let him know about the routing information of the network. Now, suppose that we have an attacker working in this PC and he is able to capture, analyze the content of this DBD packet. Then he can utilize it to launch routing table poisoning or DOS attack. Why this happen? Because now any information regarding the routing now on the segment, so he can capture it and utilize the information to launch, for example, routing table poisoning or DOS attack. Now, what is happening if this interface F00 is passive? So let us delete or stop this router, okay, and I'm gonna to stop the capturing, close the Wireshark and start it again. But before, I need to set the interface F00 to passive. So go to console of R3, configure terminal, IPv6 router OSPF1 passive, interface F00 in the configuration. Okay, now let us restart the Wireshark. We can see that there is no hello packets broadcasting from the F00 on R3. Okay, now let us do the configuration again to verify whether the F00 is sending the DBD packets. Start the R4 and open the console, copy and paste the configuration. Okay, now let us check the packets. We can see that there is no OSPF packets has been initiated from R3 to all route. This is hello packets is initiated from R4 actually, not from R3. Please note that the attacker could add a virtual router, not physical router. He can install simulation software, network simulation software, and configure a virtual router inside his PC to trick R3 that there is a new router has been added to the network. Please send me the DBD packets. I want everything about the routing information inside the network. But when you set the outside, let's say outside interface to passive, the attackers will not have any information about the routing table inside the network. So setting the outside interface as passive is very important, not only for securing your network, but also to minimize the traffic. We saw that there are too many hello packets initiated from R3 to all routers in this segment. But actually, before adding this router, there were no routers, so this packet will be useless just to increase the overload on the segment. That's all for this lab. See you in next